Hello and welcome today to API Security, What Matters. I'm James Robinson, Deputy CISO at Netskope. Happy to be here. Let's dive into it. The threat landscape is definitely something that is always evolving, right? To think that a threat landscape is something that's static is definitely going to be something that you're positioning yourself in the wrong way. Threats come, threats go, threats evolve. It's one of those things that is very hard to articulate, but is very easy to understand when you start digging into it. So hopefully you get a little bit out of it today. Some of the evolving threats, but then also how do you understand how to keep up with the threat landscape and continue to monitor it, understand it, and then use it within your daily practice. So diving in a little bit there, the one key piece about machine-to-machine identity and APIs which are using or which machines are using there is really historically machines are not well maintained. If I think about even your mechanical machines you have at your house, let's say something like a washer and dryer, do you really maintain it? Let's say your car, yeah, you maintain it, but do you really maintain it down to the level where you're looking at it from a perspective of every single day you're checking your tires? Are you checking your oil every single time you start up? And the answer is honestly no. We don't do that. We haven't done that a long time, even though the vendor recommends that we do that. And so historically, machines are not well maintained. Myself, when I worked at Emerson Electric, we knew this. We were being asked to build systems for 30 years, 50 years of operation. And all I could think about on the threat landscape is really what I knew, which was 10 to 15 years of history. And then looking forward, what would be 30 years down the road, it was very hard for me to understand. So you have to not only have that maintenance, but then also understand the evolving threats that come with it. The other piece, when you're looking at machines, it's a little bit different, is machines cause disruption and they cause real impact. And there was a really cool blog and research I did when I was going to college. It was around this space, and it was really about the Maslow's hierarchy of needs, which we see on the right. And the hierarchy of needs, really, when you get into machine and IoT and OT systems, they start to impact us at a lower level. What we see when you have credit card breaches, very high level. When you see attacks and abuse and folks that are attacking each other, you're starting to get into that steam. But when you start to take away water quality, power, electrical, other items like that, you're starting to get down into the safety, the human life, the basic elements that we need every day for us to live. And so when you look at machines and machine connectivity and where we're going, it's going to be key for us to understand and have good machine identity, have good practices in this place, and understand where the threats are today and where the threats are evolving to. Going into the next, APIs are lifeblood. So the machines cannot communicate without APIs, right? APIs, very simply, just application programmatic interfaces. It's how-to machines, how-to systems communicate. And as you start to look at systems that are running autonomously, the APIs are going to be used more and more for that command and control. In this case, good command and control. But that command and control for the communications to be established and that system to be maintained. How is health update systems, right? Watching the launch of a rocket and the video feed that's coming through, all that other telemetry and data. It's really cool watching the pilots, but at the same time, all that other telemetry and data that's coming across is amazing as well. And those are all being driven through APIs and through communications there. And then confidentiality, integrity, availability, and usability. To put it all together in the illities, as I was originally kind of shared a long time ago. That was one of my directors said, James, it's all about the illities, and you need to think about it that way. And from that perspective, confidentiality and availability sometimes have a crossover, which I'm showing over on the side, and that crossover can also then be disrupted by usability. So if a system has to come up and automatically be operating, you may not be able to establish strong confidentiality. You may not be able to establish a strong integrity of that endpoint, that system, before it goes through enrollment, and you have key exchanges and a lot of different complicated items. And so when you're breaking that down and you're looking at it, all of these are pulling on each other in different ways. And sometimes you can go too far. There are points and times when confidentiality is more important than the availability of the system or the data. And you have to understand that trade-off and that balance and understand it when you're applying the controls and putting those in place. So that's just a bit on the threat landscape, and then we'll get into how do you actually model for these. But first, let's take a look at the business and value drivers. So why are we even talking about this? I shared a little bit about APIs and the communications and machines taking advantage of those APIs. But there is a roadmap and a plan for this, and Gartner actually highlighted it very well. I love this slide where they talked about, in 2000 we had web, and then we moved to e-business. From e-business, we moved to digital marketing, which everyone loves, all the spam and all that. That's kind of when that came out. And then we moved from there into digital business, which all of us are really seeing, and we're starting to harness that market analytics and being able to understand your sales cycles and process and who your buyer is and dig into those and then feed that back also telemetry and data that's coming back into your system. So then you can change or you can support a business, even in that case, if you're an MSP and such. But that's not where we're ending. Where we're headed to is this next level, this autonomous business. And autonomous business is really where items start to operate. You can bring up systems. Those systems can automatically be provisioned. They can automatically start to communicate. They can grow. They can scale. They can size. They can size down, size up. They can start to operate on their own. They can shut themselves off. They can bring themselves online. They can do all those things, and it all happens autonomously. And through that autonomous business and through those different pieces of that pie, you're able to start to see, oh, well, that's why my systems at home, just to give it an example, that's why my systems at home need to come online and they need internet connectivity. Well, why do they need internet connectivity? Well, now we can start to get into cycles of management and maintenance. When I was actually just got back from India, and over there, a lot of the water filtration systems, obviously water quality is a big scenario over there and situation. And so a lot of the water systems that you would have in your house actually require internet connectivity so they can stay up on the filters, and the UV systems that are actually sanitizing the water and such are actually maintaining and operating right. You're getting, again, down into that lower level of the hierarchy of needs. And that is, obviously autonomous business starting to operate when you can start to get into a replacement system or new filters and those types of things. So we can just start to see that opportunity. We obviously saw it with COVID as well, and some of the opportunity there where things were driving and even systems for detection of how many people in a certain region or area actually have COVID or not, right? There's many different ways that they were detecting that. They weren't just detecting it through hospital visits, but they were detecting it through water and through other systems there. And so you could start to see where this digital and then the move into the autonomous business is happening. So this is all good. It's good news. This is going to support many different ways of business of life, more quality of life, so on and so forth. So let's get into the academics here, because I kind of outlined a little bit of the threat landscape and the business landscape. But let's dive into the academics of security. So one thing, I was actually in a conversation the other day, and this professor, he said, well, the problem with security is security's ran like an emergency room. Everyone runs around, says, this is crazy. We got another incident, another situation's going on. People are freaking out. I need money. I need budget. I need this now. I need, that, or this just happened, and I need to make sure that this isn't going to happen again. And with that, you're driving into the emergency room scenario. It's very response driven. It's very oriented in that path, and that's bad, right? One thing I was taught very early in my career was stay away from FUD, fear, uncertainty, and doubt, right? But we have become really accustomed to that, and that's how we really drive things out, honestly. And it's very unfortunate that we do so, because I think it gives the wrong message of the value of security and what it can actually provide. So security can be proactive. We can give strong requirements. We can give designs. We can actually do threat modeling. We can say, here are the threats that are associated to this. And then through that evolving threat landscape and being able to manage that, you're able to start to communicate. To relay this, or to kind of relate it back to the emergency room scenario, it's moving from emergency room to public health, right? That was the best way I could actually outline it. But the idea was, you can actually be a little more proactive. You can say, well, hey, let's brush your teeth, so then we don't have to pull teeth, and bring you into a doctor or into the dentist. Let's make sure that you're riding your bike with a helmet, so then you don't have to go to the emergency room because you fell off of your bike and you hit your head or something like that. So you can start to educate and have public health and really drive it that way. If we put it into machine-to-machine communications, what about two cars that are driving down the road and they can actually detect the speed in which they're coming at each other and the trajectory, and they know that it's only one lane, and through that one lane they know that someone has to give, and so they start to status and communicate at first. And if the user or the driver at that point doesn't step in, then it can go ahead and it can take action itself, right? And that's the idea, where you can start to get in, you can start to build this out. Now, security in that case is going to be critical in there, because what if there's someone that's a bad actor, which we will get into next. So threat modeling and abuse cases, this is really the core of the content here. So threat modeling, there's basic ways of doing threat modeling. First one, identify threats, understand those threats. You may say two systems communicating. I've done it a couple times already. Two cars communicating with each other. Well, what happens when those cars stop communicating? What happens when there's another actor that's communicating? And so on and so forth. You can break this down. You can talk about your family, your house, devices in your life, your ecosystem, and all, and how those actually can communicate, or how those actually interact with each other. That gives a really good illustration of machine to machine, and then you can put that into business terms and communicate it with the different companies on that same thing. So the one example I gave is, can my washer attack my security, fire alarm, or system? If the answer is yes, then you say how. What are the different ways? Can my washer flood the network? And through the flooding the network, my security system or fire alarm system doesn't get to use the priority of the internet if it's working over the internet. And my broadband connection, if it can't use that, then obviously that's a problem. What if I disconnected the two, but I still have my security and alarm system? What if my washer is able to make enough noise and the alarm system takes that as another alarm or something? Sometimes there'll be items like that actually it will sense loud noises and such. If that's the case, well, that's another way that my washer can detect or send an alert that the alarm system would actually pick up. So there's a lot of different scenarios that we can break down here and we can understand. That's kind of the basic level of threat modeling. The more advanced level is you start to understand what's your defensive position. So you would say something like, okay, my washer machine attacks my security and my fire alarm system. It does the attack. And how is this done? We just outlined a few different areas where and how it's done. But what controls do I have in place? Well, if it can't fill up the internet, because my network systems start to say, hey, we're starting to get overflow of internet coming from the washing machine, and that's going to be governed or that's going to be blocked, then what you could do is it could actually start to give priority to the fire and alarm system, right? In some cases, in shop manufacturing floors and items like that, the safety and control systems run on different networks, and they do so on purpose. At what point does your house have to have that same type of control in place, because the fire and alarm system is that important to you that it actually is going to be something that you have to separate from each other. And then what happens when that washing machine tries to attack the fire or alarm system directly? Well, if you have strong authentication, obviously it can't then communicate to it. And if it can't communicate to it, then you can actually say, okay, now we have a good control in place. Does the fire and the safety system then communicate back to whoever the monitoring body is to say, hey, we just saw an attack against my system internally inside of my house, and it was coming from here, and they call me and say, hey, what was this system? Because it just attacked your security or your fire system inside of your house. Those are all things that you have to think about, and you can think about. It's very easy to start breaking that down, and we're threat modeling, and we're doing so where you're also looking at what are the controls you have in place. That's your defensive position, and then you're also looking at what are those abuse cases, which we'll get into next to build out. So abuse cases are kind of fun, in my opinion. Kind of a geek, I guess you'd say. So a use case we all know. I love it when I'm in a sales conversation and someone says, well, what's your use case? Give me your 5 use cases. Immediately my mind goes, oh, here's my use cases. But I'm a security person, so I think about the abuse cases as well. A use case would be, as a user, I'm going to create a presentation, which we're seeing right here, and then I'm going to have images and words, and I'm going to share that over the internet to an audience. Well, what's my abuse cases? And this is an abuse case that I actually saw. My son actually ran into this in school. As a malicious user or admin, guest device, we'll just use malicious user, I will update someone else's presentation so they can't give their presentation. My son had that happen to him. One of the kids in the class found his presentation, updated it. He got there, he went to give the presentation. It was not very good. It was all modified. He was not happy about that. Obviously not very good authentication or controls in place to prevent from that. And then I had to work with him to go back in time, since he was doing it in actually Google, go back and actually show, here's who made the modifications. I had to show him, here's who made the modifications and here's what they did. And here's your slides right here. But that was pretty difficult, right? We can take those and we can start to pull that in. So you can say, as again, malicious user or an admin, a malicious admin, that's one where an admin may be someone who's working, but they don't know that they just clicked the wrong button. They took the system offline. They didn't know. They took the system online when key exchange was happening. And because they did that, it destroyed all the keys. Now what? that's the abuse case scenario that you can come up with. And sometimes it's not always malicious. Sometimes it's unintentional, right? So you have abuse cases that can be very malicious in nature, and then abuse cases that are unknowing or not necessarily malicious in nature. They didn't know that they were doing something wrong. So moving on, there are some pretty cool pieces of information that you can actually go to. This is actually one that me and my team actually contributed to. It was a OWASP cheat sheet. And inside of there, what we did is we started to break down epics. And with those epics, we started bringing in very generic abuse cases that would apply. So an injection attack, let's just say, on OWASP 2017, it was A1, number one. And with that, you could be able to outline, as an attacker, I will perform an injection attack, SQL injection, LDAP, XPath, whatever that might be, against the systems, right? You can insert whatever technology, against the input fields, and then of the users and APIs. So you can actually build this out as an abuse case, very simply, just like that. You can use that, you can put it in, and now you need to go through and figure out what's your defensive position, right? So you have my abuse case, what's my position against this? Can this happen? What am I doing? How am I filtering for this? How am I looking at it? And drive out from there. Now, where does all this go? So when we get into machine and machine identity, I would say that the industry has not challenged itself to figure this out. So in that abuse case scenario over on the right side, you have, here's my API interfaces. Those API interfaces, yes, could definitely be attacked. But what about the machines, and how does machine identity fit into this? So my ask, my challenge to all of you as audience is, how does this change for machines? Should we go and try to update the abuse case cheat sheet and actually have things in there for machines? How does OWASP need to be updated? Because I believe that the community needs to update this, and it needs to be maintained in that way. And if we don't do it as a community, we're definitely going to be problematic, because now you're talking about something that not everyone will understand and have good common reference for. So that's the challenge to the group here. So positioning and solution advantages. Really on this one, I would give you two different things to take away from this. One, know your use cases as you're supporting. Machine identity is huge. It's going to continue to increase. The way that interactions happen, because we're moving to that autonomous business, is going to be just out of the world. It's going to continue on more and more and more. So you're in a very key, very strategic field, being able to position this and be able to deliver it. And then also understand the risk and the offsets and the business impact. Probably a whole nother session to talk about how you position the solution to be able to get into business, and be able to drive it and drive even revenue and supported revenue and all. That's a whole nother session, but you can get there through this. And then the other piece of this is know your competition. Know what your competition does, what they don't do, and then use those as points and counterpoints that you're able to leverage to be able to say, here's an abuse case that doesn't get covered by my competition, or so on and so forth. And you can just be very transparent with those, especially if there's public reference, going back to something like the OWASP top 10 and such. So that I will say thank you.